go. Ready to go on 13.1. It's all about permutations and combinations. Yep, we're headed into the probability chapter, chapter 13. Things we're going to be working on in this one, we're going to look at tree diagrams, independent versus dependent events, permutations, and combinations. Do you remember what the difference is between these? Well, let's go through. This I just had in there. If you think about Mr. Potato Head, which you probably played with when you were a little kid, you know that there was lots of different potato heads that could be made because they came with so many different things. You got mustaches, you've got eyes that were different, you got lots of different shoes and accessories. Literally thousands and thousands of different Mr. Potato Heads could be made. So kind of fun, and it's all on this counting method and tree diagrams that you could do, like how many different ways could something happen. So tree diagrams, nice way to organize and display ways of possible outcomes. So if I looked at rolling a dice followed by flipping a coin, how many different outcomes are there? Well, I know that there are 6 different outcomes when I roll a dice. And I have them listed here, 1, 2, 3, 4, 5, or 6. I could roll any of those numbers. So I could roll my dice, and then I could follow that by flipping a coin. And my choices for coins would be a head or a tail. So one possibility is I could roll a 1, followed by flipping a coin and getting a head. That outcome would look like a 1 head. I could roll a 1 and follow that with a tail, and another different outcome would be a 1 tail. I could roll a 2 and get a head, and so forth. This tree diagram, the idea behind it is that it helps you organize all those various outcomes that you could possibly get. Now remember, with these videos, you could hit pause if you get behind and need some time to catch up. So we could put literally all the different possible outcomes in a listing over here. There should be 12 items when I get done, because I have 6 ways of rolling the dice times 2 ways of flipping a head or a tail on the coin, and that would give me 12 total outcomes. Those outcomes could be listed like this in our tree diagram. Basic counting principle, a very easy and useful method of coming up with how many different ways something can occur. Just like we were talking about with this dice. 6 outcomes for the dice times 2 outcomes for flipping a coin gives us a grand total of 12 outcomes. A very easy principle. Take the number of ways the first event can occur, the number of ways the second event can occur, and if you had more events, the number of ways times the number of ways times the number of ways will eventually multiply out to give us the total outcomes. So how many had one of these when they were kids? Those puzzle packs that had all these pieces that you could make these cute little bears. How many different bears could you make? It would keep a kid busy for a long time. I believe in these puzzle packs there were 6 faces that came with them. I think there was 1, 2, 3, 4, 5, 6 different dresses or outfits, followed by shoes, 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 6 different shoes. So it was 6 times 6 times 6, and that would give you a lot of possibilities, and I should have done that out beforehand, but I didn't. So 6 raised to the 3rd, 216. Different bear faces, outfits, shoes that could be made. Keep a kid busy, wouldn't it? Independent versus dependent events. Events that are independent do not affect one another. So events that do not affect one another. It's much like rolling a die and flipping a coin. By rolling the die, it has no impact at all on what's going to turn out on that coin. So therefore it is independent. Dependent events do affect the outcome of the next way of doing something, like picking 2 cards out of a deck where you don't replace them. The first time I draw from the deck there were 52 cards, and the next time I drew there was down to 51 cards. That first draw definitely had an impact on my second draw. I no longer had 52 cards to deal from. So independent, no effect on the second or third draw. Dependent, yes, it does affect the following event. Which brings us to permutations, which I hope many of you have heard of before. It should ring a bell. And when we get into permutations, we get into using this mathematical symbol, which of course is the exclamation point, but more importantly in math, it's called a factorial. So jot down the word factorial. And to define a factorial, we'll use 6 factorial as our example. That becomes 6 times 5 times 4 times 3 times 2 times 1. And while you could punch that into your calculator, there is a better way, and that is to use the factorial symbol. If you go, let's key our 6 first because we'll need that. Go into second math. Oops, not second math. How about just math? And we want to get into probability. So I'm going to cursor around and get to probability, and then you'll see option number 4 is the factorial symbol. I hit 4, it brought it onto the home screen. Now I hit enter, and there is our answer. 720 is what 6 factorial is. It's that downhill multiplication till I get down to 1. Now permutations, you guys. Permutations are all about arranging things or the order of things. So arranging objects in such a way that order matters. Well, what does that mean? Well, an example, like if I had the 3 letters A, B, and C, how many different ways could I arrange that? I could have ABC as one way. I could have BAC as one way. I could have BCA. I could have CBA. I could have CAB. And 1, 2, 3, 4, 5. There should be 6 ways. I'm missing one of them. How about ACB? All of those are considered unique ways of ordering things. Thus, each of them is a permutation. And the way to calculate permutations is this little formula, which I think you have jotted down. And it has that factorial symbol. So n factorial over n minus r, do this calculation, of course, and then use the factorial symbol. N stands for the total objects. So n equals total number of items. And r equals the number being selected or chosen. So usually when we read permutations n comma r, we talk about n objects being, there are n objects where we're choosing r at a time. So an example, a permutation of 5 choosing 3. I know 5 is my total number. 3 is the amount we're selecting. So maybe I wanted to choose 3 people, maybe a president, a vice president, and a secretary out of a total of 5. Well, I could do then 5 factorial because of n factorial, n being the total. Remember, this is n, this is r. And then I want to do n minus r, so I'm going to have 5 minus 3, which I have to subtract first. So I'm going to have 5 factorial over 2 factorial. And if you put that in your calculator, you would have, well, let's go do it in the calculator while we're talking about it. So once again, we're going to go into that math menu and probability. So I need to put in, let's go 5 for my total, math menu, probability, and then I want option number 2, which says choose 3 out of that. A 5 choosing 3. And the answer turns out to be 60. So really what I was keying was based on this information right there. 5 choosing 3. If I had simply n things and I wanted to choose all of them, well, the calculation would actually turn out to be just n factorial. If you do 5 choosing 5, go back to your calculator, I would have 5 math menu probability, option number 2, choosing 5, and it would turn out to be 120 different ways that that could occur. If you don't believe me, we could show you using the formula 5 factorial over 5 minus 5 factorial using the above formula. And that gives me 5 factorial divided by 0 factorial. And 0 factorial is defined as 1, so you can see how it comes back to be 5 factorial. Next up, combinations. What's the difference between a permutation and a combination? Well, combinations works more with groups of items, teams, or maybe sometimes you hear the word committees. So those 3 words especially will signal me to think about a combination. So grouping it in objects in such a way that order does not matter. For instance, Abby, Mike, and Patrick are a group of 3 people out of the 7th hour class. No matter how I arrange Abby, Mike, and Patrick, they still contain the same group of people. So they would not be unique if I said Patrick, Mike, Abby. They still count just as one combination of 3 kids out of 7th hour. Okay? NCR is how our calculator will show it. Sometimes you'll see this notation where you have a combination of n things choosing r at a time. Formula is just slightly different than permutations. Permutations does not include this little r squared. If you look at that right now, that's the permutation method. Putting this r factorial in reduces the overall effect, doesn't it? Because I'm dividing by more when I do this combination. Thus, the number of ways goes down when compared to a permutation. So 5 choosing 3, here's my n, here's my r, and then in the calculator, there is another way to select that. What were we doing? 5, 3. So I can put 5 in, hit math, go to probability, option number 3, and now I've got to fill in my r amount, and r amount was 3, so I put in my 3, hit enter, and it tells me now that there is 10 ways for this to occur. If you remember from the screen before, look at your slide before, a permutation of 5 choosing 3 turned out to be 60 before. So a large difference in the way things are organized, permutation versus combination. If I have a combination where the number and the number match up, so I've got n things and I'm choosing all n of them, it will turn out to be the 1. There's one way of choosing 5 things out of a total of 5 because I can make one group of those 5 items. So that turns out to be 1. All right, now there's just a bunch of examples and let's walk through a few. I'm at 13 minutes, so I'm not going to be able to do all of them, but we'll get a start. Every year, Popular magazine picks 15 top-rated TV shows of the previous year. The network wants to select 3 out of these 15 movies to show during the month of August. How many groups of 3 movies can be selected? Well, when I was reading this, they talked about a total of 15. They said they wanted to select 3. So I kind of, in my mind, I know my total amount is going to be 15, and I know my R is going to be 3. I want to select 3. Now, the biggest question is this a permutation or is this a combination? And I can decide that based on this word, this very, very, very important word, groups. Highlight it if you got a highlighter. Groups lead us to what? Groups lead us to combinations. So I really, truly want to do a combination of 15 things, choosing 3, and put that into the calculator. 15, math menu, probability, option 3, I'm choosing 3 things out of 15, and I see my 15 didn't quite go in. So 15, probability, choose 3, hit enter, and we are at 455. That's a lot of different groups of things to conclude. All right, we will work with the rest of these when we get to class time. Thanks a lot.